Alright, hello everyone. We are going to be discussing serotonin, otherwise known as 5-HT, which is a neurotransmitter. So neurotransmitters follow this cycle of release. So in order to understand the cycle, we must be familiar with the presynaptic neuron and the postsynaptic neuron. So the presynaptic neuron is what is activated by an action potential and then releases neurotransmitters using vesicles. So you can think of vesicles as these little pouches that carry the neurotransmitters and will travel down the neuron to fuse with the membrane. So just like open up so that it can release the neurotransmitters. And then after that, the neurotransmitters will then travel down this space right here called the synaptic cleft. The synaptic cleft is just the space in between the presynaptic neuron and the postsynaptic neuron. So the neurotransmitters will travel down this space and bind to these special receptors on the postsynaptic neuron. So the postsynaptic neuron is what receives the neurotransmitters. So going back to these receptors, what's so special about them is that they are a certain shape and designed so that it can bind to serotonin and nothing really else. So a lot of people like to think of it as a lock and key because the receptor is the lock and the neurotransmitter, or in this case serotonin, is the key. So with that in mind, we can now talk about exocytosis. So exocytosis is just the cycle or the process of which neurotransmitters are being released. So you guys are already familiar with the release part, but we are going to be talking about the final stage of exocytosis, which is reuptake. So reuptake takes place after the reaction is over. So as you can see here, the serotonin is all binded to the receptors, nothing else can be done, they did their job. So what they're going to do now is unbind from these receptors and then travel back up into the synaptic cleft, where one of two things can happen. So they can either be broken down by an enzyme. So the enzyme will break it off into two parts, and the neurotransmitter, or those two parts, will now become inactive, can't do anything anymore. So then that's one thing. And then the other thing that can happen is called reuptake. So the neurotransmitters will be in the synaptic cleft and then be taken back up using autoreceptors, or in this case, serotonin reuptake transporters. So then they can be brought back up into the presynaptic neuron. And a lot of people like to think of this as recycling. So we're just reusing the same neurotransmitters and saving them so that we can use them in the future. So in terms of selective serotonin reuptake inhibitors, what they do is block this reuptake stage. So in other words, they inhibit the serotonin reuptake transporters' ability to take back serotonin back into the presynaptic neuron. And what this means is that with the remaining neurotransmitters that aren't broken down by enzymes will stay in the synaptic cleft. So the serotonin concentration will increase, and what this means is that there will be more serotonin that can bind to the postsynaptic receptors. And what this will cause is a bigger reaction in the postsynaptic neuron. Whether it be inhibitory or excitatory, it really depends on the receptor. So with that is the role of selective serotonin reuptake inhibitors in the case of serotonin.